so we'll just continue with some examples. We have in this question the temperature T in degrees Celsius, it's measured in, of the air varies inversely. That's what we're looking for, those words. So we know we're doing an inverse proportion question. With the height, which they're calling h for the symbol, and it's measured in metres, above sea level. Okay, then they tell you at 150 metres above sea level, the temperature is 30 degrees Celsius. So they're giving you a pair of numbers that go together. And then the question says, what is the temperature at 300 metres above sea level? We have a lot of work to do before we get to answer that question. Okay, so we're going to first start by trying to get our variation equation. So we have T varies inversely, H. So we're going to write T equals K over H. Make sure you stick with the letters the same way they've written them. This is a capital T and a little h. Alright, so that's the start of our variation equation, but remember we have to find the K value. So we're going to find K, and to do that we need a pair of values that go together. So we need a T and an H that go together. And that's what they're trying to tell you here. That's what the two numbers are for. So we've got 150 metres above sea level. Now that is H, so it's 150. And they told you the temperature is 30 degrees Celsius, so 30 is T. So we're going to put those numbers into here now, and we have 30 equals K over 150. So we're going to solve that equation to find K. So we want to get K by itself. So we want to get rid of the divided by 150 and take it to the other side. So we'll just move the 30 over, do the opposite of divided by 150, which is times 150. And use your calculator to work that out. And you'll get 4,500. So we're going to put that K value back into our variation equation to create the formula we need, which will look like that. So that's the formula that you're going to use for everything. Okay, so we're going to finish this now by answering the question they wanted to know, which is what's the temperature at 300 metres above sea level? So we're looking for the temperature. The 300 goes in here for H. Okay, and then we're going to work that out. And if you get your calculator and work that out, you'll get 15. And it's degrees Celsius for the units for the T for temperature. Okay, so your answer is T equals 15 degrees Celsius. All right, the next question is asking for the height above sea level when the temperature is 8 degrees Celsius. So we're going to start with our variation equation or our formula that we just found up here. And we're just going to use it now. We're just going to sub in what they've given us. They told us the temperature was 8. So we're going to put the 8 in here. And we're trying to find H. Now remember, if you have a letter on the bottom, we're going to do the swap. I've told you about this before. So if there's a letter on the bottom of a fraction, we're going to swap it with this. And now we have H equals 4,500 over 8. So the H and the 8 swap spots. Okay, so now we've just got to work this out using our calculator. Bear with me, I've just got to go and get it. All right, sorry about that, should have been ready. All right, so I'm going to put that in our calculator, 4,500 over 8. And we end up with, now if you're getting an improper fraction, just press the SD button and you'll get 562.5. And so that's our H. Our H is our metres above sea level. And that's what they wanted to know. What's the height above sea level? So that's our answer. Okay, now in part C we're doing a graph. All right, so we're graphing the relationship between the temperature, which was T, remember, and the height above sea level, which was H. Now remember, we just got that formula. Here it is. We'll write it down again. So we want to graph that. Now they've given you a little bit of a hint here, so we're going to start our graph. And when you're doing this, you've got to remember that normally we have x's and y's, don't we? And it normally says y equals, and then it's got something with an x over the other side. So whatever's here is on the vertical axis. Okay, that's normally y, all right? And we normally have a y-axis there. So in this case, we're going to have t on our vertical axis. That means we're going to have h on our horizontal axis, and they've told you what to use here. They want you to start at 0 and go to 3,000 and jump up in intervals of 500. So we'll just see what that looks like. Hopefully I'll do this vertical axis far enough. If not, we might have to change things. We'll see how we go. All right. So down the bottom here, we're starting at 0, so we don't need any negative part of the graph. Then we're going to go 500, 1,000, so 500, 1,000, 1,500, 2,000, 2,500, 3,000, and we're going to stop there. Okay, so let's just put those on. I'll just write them sideways because it's easier to see where it all comes from. Okay, so that's what they've asked you to do. Now, that is your h-axis. So put an arrow on the end and write h. This vertical axis is going to be t. And you really should write what units they're in. All right, the temperature was in degrees Celsius. And the h was in metres. I might write the word rather than an M, just in case we've got too many letters floating around. Okay, so now we're going to actually graph what we know so far. So if we have a look back on what we've done so we don't have to do too much extra work, back here it said what's the temperature at 300 metres above sea level, and it was 15. So 300 metres above sea level would be about here, and it went up to 15. All right, and then the other thing we know is this one here. So I'm going to come back here and try and write this as a point. All right, so our h is going to be our first coordinate, and in this one, our h was 300, so that's our h, and our t was our second coordinate for our vertical axis, and that's 15. So we've basically got a point 315. Down here, what's our h? It's 562.5. Okay, and what's our t? It's 8. So I'm going to try and mark those 2 points on just to see where they are. All right, so it looks like our temperature, we had a 15 degrees Celsius here and an 8. So we're not going up very high in temperatures, are we? So we know we've got to go up to at least 15 here. So I might just go up in 3s maybe. That'll be 15 there. I might go a bit further and just see how we're going. So I'm deciding to go up in 3s for the time being. But I'm leaving some space above it in case we need it. All right, so let's see if we can put these points on. We've got 315. So along to 300, which would be about there, and up to 15. Try and do this as accurately as I can. That's that point. And the other one is 562.58. So go across to 562.5, I don't know, it's about there. And then up to 8, which is about here. And we've got 2 points that look like that. Now, it doesn't help very much because it doesn't look like we haven't got much to go by here, those 2 points. So we might see what happens if we pick something a bit further along here and see where those points are. So if we want to have a look and just find some extra points, I'm going to let H equal, let's pick something easy. Maybe 1500 and see what happens there. And then put it into our formula. I'm going to put a 1500 in here. Now if you go to your calculator and do that, you're going to get 3. Okay, so we've got 1500 across, 3 up, and we've got that point there. Now that's really enough to draw our graph. I hope you can see what these dots are doing. They're definitely not in any straight line at all. And what they're doing is they're in a curve. So we're going to join these 3 dots in the curve that they're in. I'll just use my red pen so you can still see those points. And it goes like that. Just put arrowheads on the end. There's the 3 points. And that's our graph. Okay? And it's actually, it's a little bit like one of the other graphs we've done before, like the exponential graph, but it's actually called, it's part of a hyperbola. We didn't really do those graphs. They used to be in Year 10, but they're not anymore. But that's the sort of thing that happens when you look at something like the marijuana in the body. Okay, I think I've spoken to you a little bit about this before. So it's a bit like one of the exponential graphs. So it's never ever going to go and get to 0. It will always stay in your body, but it will continue to become very, very small amounts. Okay, so these graphs are actually used for other things. All right, so I'm going to look at number 5 now. I'll just move this over a bit so you can see it. And this sort of question is really, really badly done in tests. So I want to go through one of them so you can see it. All right, and they ask these sort of things in maths competitions as well, and they're never very well done. Okay, so it says here the amount of time it takes Sarah to move house is inversely proportional, there's those words, to the number of friends she has to help her. So in other words, the more friends she has to help her move house, the less time it's going to take. And that makes sense, doesn't it? More friends helping, less time. When she has 4 friends helping, the job takes 3 3/4 hours. And then they ask how long, in other words, what time, will it take if she has 6 friends helping? A lot of people think they know what they're doing with this, but they really don't. Okay, so we've got to go back to our inverse proportion variation equation and start with that. So they have not given us any help with letters here, so we're going to make up our own. Sorry, I'll just move this back a little bit. All right, so I'm going to say that time is T, and I'm going to say that the friends is F, and we'll go from there. Okay, so we're going to write T inversely proportional, so it's equals K over, and then the F. All right, that's the start of our work. We're now going to find K, and we need 2 numbers that go together. All right, so here it tells you that the time was 3 3/4 hours, and the friends, there were 4 of them. Okay, so we're going to put those numbers into here. So T was 3 3/4 equals K over, and the friends was 4. So we're going to solve that little equation and see if we can get this K value. So we're going to get rid of the 4. So the opposite of dividing by 4 is timesing by 4. So we'll come over here, put down K on the right, 3 3/4. We're going to do times by 4. And if you do that, you're going to get 15. Okay? All right, now, once you get your K value, you've got to put it back into this equation. So we're now going to have our formula, which says that. And now we're going to use our formula. So it says, how long will it take? We're finding time. If she has 6 friends helping, so you put 6 in for your friends. Now you go to your calculator and you put in 15 over 6 equals. Now if I do that, watch what happens. Calculate a fraction key, 15 over 6. All right, and if we do that when press equals, we get 5 over 2, which is not much help to us, so we're going to press SD. So it's 2.5. So 2.5, and it's time, and the time they were talking about was in hours, so we're talking in hours as well. So you can just leave your answer like that, it's fine. All right, now let's look at the next one. How many friends? So we're looking for F this time. Start with your formula that we created. There's your formula. Now we're going to use it. We're looking for friends. Not literally looking for friends, but we're looking for the value of the number of friends. Okay, and the time is 3 hours, they've told you here. All right, what do we do when that letter's on the bottom? We swap it with what's over here. So swap positions. F is now here, 3 is now here, and use your calculator to work that out. You're going to get 5. So it's going to be 5 friends that are needed to get you moving in 3 hours. Okay, so I hope that's clear. But as I said, these questions, like this one here, is hard. The reason it's hard, for a couple of reasons. A lot of people think they know how to do a question like this because they think, oh, that makes sense. I think I can do this without doing all of that stuff. If they say inversely proportional, please do it with inverse proportion or you're going to get them wrong. Okay? Sometimes they won't even use those words in a question like this. They could quite easily have said, the amount of time it takes Sarah to move house is 3 3/4 hours with 4 friends. How long is it going to take her with 6 friends? And they won't tell you anything about inverse proportion. Now, if they do that, you've just got to think about common sense. If I have more friends, increase the number of friends, will that take me more time to move or less? It'll take you less time. Once you see the opposites happening, you know it's inversely proportional to. Okay, now, so they don't need to really tell you that, but they've told you to help you a little bit here on this question. Okay, so good luck in the homework, but you do need to practice it.